Now we are going to talk about computer vision, and I have Maya joining us from Israel. She is a 16-year-old student at Tel Aviv University, and at such young age, she has built a very useful tool, which is quite relevant for the time that we are in right now, the COVID-19 pandemic, and how she uses computer vision to help us out in this situation. Without further ado, I will share the stage to Maya.
Hi, hello everyone. I'm Maya, and I'm excited to showcase Don't Touch Your Face. So, Don't Touch Your Face is a website that allows you, that detects when you touch your face and alerts you about it. So this is the website. As you can see my face, and I can load the model that I've trained beforehand. And whenever I touch my face, it detects it and it beeps. And the really interesting thing that it's all on browser, and I can actually train it on browser. So for example, if I want to train it to perform a bit better, to not detect when I'm, for example, moving my hand over my face, I can just train it on browser like this. I'm pressing this button, which is training it right on browser, and I'll explain it soon. So now I want to share how I built Don't Touch Your Face. So the main tools powering Don't Touch Your Face is React.js on the front end, and then TensorFlow.js and a pre-trained neural network. And the most interesting thing is that it's all happening right on the front end. There is absolutely no server running and processing the faces or whatever. It's all running on your computer on the browser, which is really powerful. So the main technology powering this is a type of machine learning called transfer learning. And transfer learning is a research problem in machine learning that focuses on storing knowledge gained while solving one problem and applying it to a different but related problem. So maybe we have a solution to some machine learning problem and we want to apply it to solve something in the same domain, but a bit different or perhaps more specific. So again, what we want to do is when we want to take a general machine learning model and make it more specific. Now, it may seem counterintuitive. Why would you want to make something more specific and so maybe less generalized? But it actually works very well. So there are two main parts. One is the pre-trained MobileNet model. So MobileNet is this huge convolutional neural network trained on, I think, 14 million images, and it has like 30 layers, if I remember correctly. And it basically takes in an image of anything, really. You can take a cat or a ball or anything, and it outputs a set of categories of what is that thing. And then we take this result on the face and we train it on browser using a k-nearest neighbors model, and we just output and make it more specific to just output not touching or touching. So to illustrate how this works, I'm going to take a simpler example of maybe taking an image of a dog and outputting, is it a large dog or is it a small dog? So suppose we have an image of a dog and we feed it into MobileNet. So it outputs this set of categories. So maybe in 73%, it's a Labrador Retriever, and 4%, it's a Rhodesian Ridgeback, and so on. So it's this huge set of categories. Now, this set of categories doesn't tell me much about, is it a large dog or is it a small dog? So what I may want to do is to gather a data set. Actually, one of the most powerful things about transfer learning is that it doesn't require much data because most of the data is already feed it into the pre-trained model. And so I can take a small data set of just large dogs and small dogs and feed it into some smaller model that takes in the output of the mobile net and outputs what I actually want. So what we have in our app is a k-nearest neighbors model, which is basically the simplest machine learning model you can imagine. All it does is it takes some input and then it looks at all of the inputs it has so far and takes the k nearest ones and then just takes the majority vote. So like if the nearest examples to it were large dogs, then it will say, yeah, it's a large dog. So just by similarities. So we train a k-nearest neighbors model that takes in the output of the mobile net. Here a dog, in our case, features about the face, and outputs small dog or large dog, in our example, touching or not touching. And again, this is all done on the browser right as I'm pressing the button. And so it's all done using TensorFlow. And this is the code, and I'm going to give a quick run through of the code. So we're importing MobileNet, which is this trained neural network. We're loading it. And then each time we get an image, we take it from the video element. We run the MobileNet on it. We infer, we run the prediction of the MobileNet. And then if we're training, we add it as an example to the k-nearest neighbors model. And whenever we're predicting, we're first running the MobileNet model, we're inferring, and then we run the k-nearest neighbors over it, and that's our prediction. So thank you for listening. You can run Don't Touch Your Face right now at https://www.don'ttouchyourface.ml. And you can learn more on Google Teachable Machine, which is a wonderful website that allows you to do transfer learning right on the browser. It's really great. And that's it. Now we have time for questions and answers.
Great. Thanks a lot, Maya, for sharing this, your breakthrough project with us. And it's quite useful. To the audience, you can ask the questions in the question answer chat section on live.gitcommit.show. If you're watching somewhere else, please go there and ask the questions. I'll ask the questions on your behalf to Maya. And Maya, so you talked about transfer learning. You used transfer learning to build this. You used trained this mobile net model and made it more specific for this specific use case, and there are other things. So what could be another for the next version? What do you think there could be more things which can improve this existing project? Also, what are the challenges that you are seeing right now in this project which can be improved?
Yeah, so about the challenges, there's a problem that because I'm training it on my specific face, so for example, if someone else walks in, it sort of destroys the model. So I'm thinking of using a different approach, either using a more specific neural network as the base model, one that is already trained for faces, instead of super generalized mobile net model and then training it, or using something better than a k-nearest neighbors in the second layer.
I see. Perfect. So we have some questions coming, but before asking those questions, I'll ask those questions. So you please keep sharing your questions in the question answer chat section. Before that, I would love to know more about how did you made this at such young age? What were your thoughts, or how did you get into this field? How did you get excited about computer vision and solving this problem? Can you share a little background about that?
Yeah, so yeah, I started coding at a really young age, maybe 10 years old. And so maybe a few years ago, I started being really interested in machine learning, and I started trying to make artificial intelligence for games. That didn't really work out, but I did begin to study machine learning through various resources. I learned TensorFlow and so on. And so during the pandemic, I thought everyone is talking about stop touching your face. And I decided that I could do good with my knowledge and actually create a website that could help people with it.
Awesome, great. So people are asking if you have any Google Play Store? Do you have you made an app, or is it just browser based?
No, I haven't. So right now it only works on the browser and only works on the computer. But that's actually a really good idea. I might do that.
Right. And we have another question which says, why didn't you use the SVM classifier?
Um, I used K-nearest neighbors, and I worked. That was the first thing I tried, and it actually worked really well. So I kept it. But that may be a good idea. I may try to implement it.
Interesting. So where can people go to try out your solution, or if there is an open source code, is it there?
Yeah, you can see the website and run it on your browser at don'ttouchyourface.ml, and the source code is available on my GitHub page, M. Farber Brodsky on GitHub.
Great, perfect. So do share that with us, and we will share with the audience this link and the GitHub page.
Yeah, great.
Okay.
This is the link.
Great. So thanks a lot, Maya, for joining us. Do you have any last message to share with the audience?
Thank you for listening, and I hope you try to use your knowledge to do good.
Awesome. Thanks a lot again, Joe, for joining us, and all the best for your project. We love to see that it becomes more, we get more adoption for this project. Thank you very much.
Thank you.